Kia ora and welcome to this quick video going through question 2 of the Level 2 algebra paper from 2013. As usual, if you have a go at the questions first, you'll get more out of it. So the first part of question 2 has got two easy simplifying questions. The first one, we're just going to expand out the brackets on both lines and we get this. So 4a squared cubed over 8a to the power of 5 squared is equal to 64 a to the power of 6 divided by 8 squared is 64 a to the power of 10. So remember, the rule here is that I am going to multiply the powers. Right, so I can simplify that and I just get 1 over a to the power of 4. Okay, it's also fine to write that as a to the negative 4. Right, question B1. So we've got 16 x squared to the power of 1/4, which is simply 16 to the power of 1/4 times x to the power of 2 times 1/4, which is 2/4. That simplifies to x to the power of 1/2. So the 16 to the power of 1/4 is the fourth root of 16. That's one that you should recognise straight away. So that's 2 root x. Okay, also fine to leave it as 2x to the power of 1/2. Or you can write the really ugly 2x to the power of 0.5. Any of those three will get you a little achieved tick. Okay, the question's starting to get a little bit harder. Okay, so part B, simplify this one. So just writing this out again, 16x squared to the power of 1/4 times 9x cubed to the power of 1/2. So we just go step by step. 16 to the power of 1/4, whoops, 1/4 times x to the power of 2/4, which is 1/2, times 9 to the power of 1/2, times x to the power of 3 over 2. I don't know what that thing there is, just don't worry about that. So that equals, well, the fourth root of 16 again is 2. X to the power of 1/2 plus 3/2 is 4/2, which is going to give me x squared, times the square root of 9, which is 3. So my answer here is 6x squared. Okay, in the next question, Lara says she's thinking of a number. So we're going to start, as usual, with let number be x. So what does she do to the number? Well, she takes x and she squares it. Then she multiplies this by 6. And then she adds 12 times the number she was first thinking of. So x squared plus 6x squared plus 12x. And then she subtracts 48. And she gets 0. So you can see we're going to have to solve a little quadratic. I'm going to do that on a new slide. Okay, so the quadratic we've got to solve is 6x squared plus 12x minus 48 equals 0. First thing I'll do is divide through by the common factor of 6. I get x squared plus 2x minus 8 equals 0. Factorising it like this, I get x plus 4, x take away 2 equals 0. So x is equal to negative 4, or x is equal to 2. Right, two questions left. Now both of these next two were excellence questions. Probably the easiest two excellence questions in the paper for 2013. The first one is to make x the subject of this equation. Right, we've got x is in the power, so your instinct should tell you to take logs of both sides. So x log a is equal to x minus 1 log 5. We can expand this to get x log 5 minus log 5. And we've still got x log a on the left hand side. Now I want to collect up the terms that have got x's in them on one side. So we'll go x log a, take away x log 5 is equal to negative log 5. Now take out the common factor of x as follows, and finally divide through both sides by this term here. So we get x is equal to negative log 5 divided by log a minus log 5. Okay, last question. The equation 3x squared plus 4x minus k equals 0 has two distinct real roots. So when you see that, you might start to think about the discriminant, and we could answer this question using the discriminant, but we've got another clue coming in the next line, and that will make it easier. If 2 is a root of this equation, find the value of k and the second root. So if we think about factorising this, we know that it equals 0, and we know that 2 is a root of the equation. So that's telling me that one of the factors must be x take away 2. Now if I look at 3x squared, I must have 3x here, and then something else. And I don't know about the something else. Now I'm going to call it n. You can call it whatever you want. I've chosen that because it matches what they've used in the assessment schedule. So what can we do next? Well, we can expand out this equation and see what we get. So we get 3x squared plus nx, take away 6x, minus 2n equals 0. So from this we know two things. We know that 4 must be equal to n take away 6. Right, so I've skipped an intermediate step in here, and I'm going to go and put that back in just to make sure you've got it. So we could write this as 3x squared plus n minus 6x minus 2n equals 0. Okay, so that's better. So what we're doing now is we're doing a strategy where we match up what we want, which is 4x, with what we've got in the expansion, which is n minus 6. And we can also see that we've got negative 2n here, or minus 2n, and we're going to match that up with the minus k. Okay, so the easiest thing to do is to solve this equation here. So we get n is equal to 4 plus 6. And we can pop that back into the equation, and we get, so that's 10. 3x plus 10 times x minus 2 is equal to 0. And when we expand that, we will find our value of k, or we could find our value of k by looking at this. So we've got 2n is equal to k. K must equal 20. The other thing we're asked to do is to find the value of the second root. So we found the value of k, and the value of the second root comes from solving 3x plus 10 equals 0. So we get x is equal to negative 10 over 3. Okay, so if 2 is a root, find the value of k. Have we done that? Yes. K is equal to 20. Have we found the value of the second root? Yes. The value of the second root is negative 10 over 3. On the last two slides, you can have a look at the assessment schedule and see how the marks were allocated. As I said, parts D and E were excellence questions for question 2.